Now, see this question. Derive the expression for maximum safe speed with which the vehicle should be moving along a curved horizontal road and state the significance. Now, in this question, you can see there are two parts. One is you have to derive an expression, okay, and the other is you have to state the significance. So, the first part is you have to find out an expression for the maximum safe velocity, which is called as Vmax, and the second is the significant part. Now, what we'll do is we'll first understand the expression for maximum safe velocity, and then later we'll find out the significant part. So, initially I'm just going to focus on the first section, expression for Vmax. Now, here also the question says find out the maximum safe velocity for a vehicle moving along a curved horizontal road. This is a very important thing you have to read in the question. Please understand that the maximum safe velocity derivation is for two conditions. For a vehicle moving along a horizontal curved road, and there is one more derivation for a vehicle which is moving along a banked road. When I say banked road, you can understand like this is the banked road, right? So, the vehicle you can see is elevated. The road surface is slightly elevated with respect to the horizontal surface. This is nothing but called as banking. So, read the question again and understand. They are saying maximum safe velocity for a vehicle moving along a curved horizontal road. So, you need to derive an expression for this condition and not for this condition. Okay, so be very careful to read the question properly. If they say for a banked road, then in that case the angle of banking concept comes and the derivation is different. And when they consider a horizontal road, there is no angle of banking, there is only frictional force for which the derivation is different. So now let's move on and understand how do you derive an expression for this maximum safe velocity. Now, to find out the expression, I have just considered a diagram over here. Now, if you see this diagram, there's a car which is moving along a curved road. Let's say over here this car has got mass of m and it is moving with some velocity. Okay, let's say the magnitude of the velocity is represented as v, and in this case you can see it's moving along a curved path. This curved path is actually a part of a circle. So basically this will be having a radius of curvature. Let the radius of curvature of this curved path be represented as. Now, as you can see, I have written over here, first we need to understand what are the forces which are acting on this vehicle. So what are the forces acting on this vehicle? Now, this vehicle is moving along a curved road, okay, and as it is moving, according to the equilibrium conditions, vertically there are two forces acting. The first vertical force over here is its own weight, which is acting downward. The weight of the car represented as mass of the car into acceleration due to gravity, mg. And you know, as it is in an equilibrium or a balance condition for no motion in vertical direction, then in that case obviously the vertical forces are balancing each other, and according to the Newton's third law, to every action there is an equal and opposite reaction. So there might be a normal reaction force acting on this vehicle. Let us represent it as N. Okay, so just to summarize, the vertical forces are balanced and the two vertical forces are, one is nothing but the normal force, okay, represented as N, and the other is nothing but the weight of that vehicle, which over here is represented as mg. Okay, now other than this, as it is moving along a curved road, or you can say a circular path, a part of a circular path, there would be an outward force and an inward force. How do you represent the outward force? This is the direction of the outward force. And how do you represent the inward force? Yes, this is the direction of the inward force, right? Now, in this case, if we see the inward force and the outward force, they might be also balanced. And in this case, what are the inward and the outward force? Ideally, we call the outward force as, yes, we call it as centrifugal force. And what is the inward force? The inward force is called as the centripetal force, the real force. Okay, the pseudo or the imaginary force, centrifugal force, and the real force, centripetal force. Now, if I consider the real force first, because that is the actual thing which is happening over here. What is the real centripetal force which is keeping the car from skidding outwards? Obviously, it is nothing but the frictional force between the car tire and the road surface. Let's call this frictional force as F. And in this case, let the centrifugal force which is acting in the outward direction be represented as capital F. So, just to summarize over here, there is a centrifugal force which is same as the centripetal force, which is represented as F. I'll call it over here, I'll write it over here, centrifugal centrifugal force represented as F, and there's a real centripetal force in the form of frictional force. I'll call it as friction or frictional force, small f represented over here. Now, if the car is moving with a higher velocity, what happens to the frictional force? Obviously, when the car is moving with a higher velocity, you know this centrifugal force is given by a formula as mv square by r. Mass of the car, velocity square, velocity with which the car is moving along the curved path, and r is the radius of curvature of this road part, curved path. So, keeping the mass of that vehicle constant, keeping the radius of curvature constant, if I go on increasing this velocity of the car, then what happens? If I increase the velocity, the force will also increase, the centrifugal force. Centrifugal force will increase means it will try to pull, or in this case try to move the car in the outward direction. But then this frictional force, which is an action reaction force, it will try to pull in the car, or the grip between the tire and the road surface will try to quantify, or you can say balance the centrifugal force and try to keep the car on the road. Now, as the centrifugal force goes on increasing, as this force goes on increasing, the frictional force will also go on increasing. As I said, it's an action reaction force. But then there is a limiting value to this frictional force. Okay, means after that limit is crossed, then the car will start skidding outwards. Now, what we need to find is, what is that maximum velocity with which the vehicle can move so that this big centrifugal force is balanced by the frictional force. Okay. And after this, if the velocity is increased, then the friction has crossed the limit value and the frictional force will no longer be able to balance the centrifugal force and it will start skidding. So, I hope you understood what we have to find out now. That is the maximum force, velocity with which the vehicle can move safely along this curved horizontal road. So, now let's move on to the derivation part. Now, as you are very clear, how many forces are acting on this vehicle which is moving along the curved path? There is the vertically normal reaction force, there is a weight which is vertically acting downwards, there is a centripetal equal to centrifugal force which is acting in the outward direction, and there is a frictional force. I'll represent it a little bit outwards over here so that you can see it. The frictional force which is acting in the inward direction. Okay. Now, how do I start with the condition? I can start this way. Since the car is in dynamic equilibrium, the outward and the inward forces are balanced. The centrifugal is equal to centripetal force. And the centripetal force over here is the real force of friction. So, I can say the centripetal force F, or the centrifugal force, is equal to the frictional force. I'll call it as small f. Now, you know this centrifugal force can be written as mv square by r. And the frictional force, by definition, you know, friction is written as coefficient of friction into normal reaction. Now, here I am considering a condition of that velocity for which the friction is just balancing the movement. So, this velocity over here is that maximum velocity. I'll call it as V max. That maximum velocity for which the vehicle is still safely moving along the curved path. And this frictional value, I'll call it as mu s. This is that limiting friction, last limit friction for which it can grip and keep the tire on the track, after which it will also fail. So, I need to find out that velocity. So, I am considering let Vmax be the velocity with which the centrifugal force and the centripetal force, that is the frictional force and the centrifugal force, are just balancing each other, for which the frictional force is the maximum force, for which the coefficient of friction is mu s. So, I get this condition mv square by r is equal to mu s into n. Now, you can see that the vertical forces are also balancing each other. So, obviously, in that case, for normal reaction, I can write mg. So, if I write mg, what do I get? mv max square upon r is equal to mu s into mg. In this case, mass cancels on both sides. If I just rearrange this and take Vmax on one side and take a square root, I get Vmax is equal to mu s into r into, which is your final expression. So, the maximum safe velocity, you can see the maximum safe velocity always depends upon three things. One, the acceleration due to gravity, which is constant for a given condition. The radius of curvature of the road, which is also a constant, okay, because in this case, once a road is constructed with a curve, the curve doesn't go on changing For a given particular patch of the road, the curvature always remains constant. And the third thing it depends upon is mu s. What is mu s? Mu s is the coefficient of friction. So what do I can say, conclude over here is that the maximum safe velocity, it depends on the friction part, right? The coefficient of friction. And this is the expression for maximum safe velocity. Now why I am specifying that Vmax depends more on the friction is because I need it for the second part, which is state the significance. So let's go to the second part. How do we state the significance of this maximum safe velocity? I hope you are very clear with the derivation. How do we start? We first of all visualize a car moving along a curved road. For that car, the horizontal forces are balanced, the vertical forces are balanced. The vertical forces are normal reaction and the weight. The horizontal are the inward frictional force, the real centripetal force, and the outward centrifugal force. We start the expression by saying that the centripetal is equal to centrifugal, which is nothing but equal to the frictional force. We substitute the centrifugal force as mv square by r. In this case, since it is moving with the maximum velocity after which it will just slip or the friction will collapse, we call the velocity as Vmax. So we read it as m Vmax square upon r. For friction, by definition, we represent it as mu s into n, where mu s is the limiting coefficient of friction. In place of n, we substitute mg. Cancelling m, we get Vmax formula. And this is the derivation. Now please understand, I've written only this much, but then this is the core part of the derivation. Apart from this, you have to decorate this answer. What do you mean by decorate this answer? Decorate means you have to write a paragraph illustrating what is m, what is r, what is v, what is n, what is mu s. All these things have to be illustrated. Means your derivation will start first by something like this, if you can see. Like you need to write, consider a vehicle of mass m, moving with a speed of v, along a horizontal road with a radius of curvature r. All these things have to be mentioned. Only then after that you will write this expression. Okay. So please don't write only the expression. You have to decorate your answer. You have to explain the examiner what is what in this derivation. So a small paragraph about the expressions which you are using and then this derivation. Now let's move on to the second part. State the significance. Now for understanding the significance, first of all, you are very clear that this maximum safe velocity formula is given as root of mu s rg. As I told you earlier, the radius of curvature and g, small g, are constant for a given condition. So then the maximum safe velocity depends on friction. So the first significance is maximum safe velocity, that is Vmax. It depends upon friction. Very, very important. Friction of what? Friction between the tire and the road surface. So if the tire has got lot of grip, okay, then in that case, the coefficient of friction over here between this tire and this road surface over here, this coefficient of friction might be very high if the tire is having a very good grip, or the road is having no impurities, no slippery part, no wetness, no oil on the road. So in that case, the coefficient of friction may increase. And correspondingly, the maximum safe velocity for the car will also increase. So what we understand from here is this maximum safe velocity is not a constant. It depends on friction, and friction of what? Friction of between the tire and the road surface, which is the first significance. Now, the second significance over here is friction, it depends on the nature of the surface. Okay, nature of the surface means what? First of all, you understand that this road surface, it could, suppose if it is a rainy season, okay, there's a lot of water or the road is wet or there is some oil spillage on the road or there is sand on the road. Now, all these things, decreases the frictional value. And if frictional value decreases, what will happen? The maximum safe velocity for that particular curved road will also change. So the first thing you need to understand is that the maximum safe velocity depends on friction. Friction between what? The tire and the road surface. And second you need to understand is this friction again depends on the nature of the surface. Okay. The third significance is that if the friction is not sufficient, okay, then the vehicle is likely to. Now let me make you understand this properly. Suppose if I consider a vehicle which is very old, having a very old worn out tire, okay, and on the other hand, on the same curvature of the road, there is a sports car which is moving, which has got very good radial tires with a very nice grip, okay. Then in this case, obviously the frictional value for this very good grip tire will be very high, and correspondingly the maximum safe velocity with which this sports car can travel will also be very, very high. But if I consider this very old car with a very old tire on it, obviously the tire is completely worn out. Obviously in that case the coefficient of friction would be less, and correspondingly the maximum safe velocity with which this old vehicle can travel will also be very less. Now suppose if I calculate the maximum safe velocity considering this very good tire grip, and let's say the maximum safe velocity for this sports car along this curved road is something like 20 meter per second, and for this particular very old vehicle having a very old worn out tire, since friction is less, coefficient of friction is less, the maximum safe velocity for this vehicle will be also less. Let's say it is something like 10 meter per second. Now if I calculate as per this sports car, and on this curved road, if I keep a speed limit, I keep a big board, on the board I have kept the maximum safe velocity on this curved road is 20 meter per second. Then what will happen? This car will try to move at this velocity and obviously it will skid out, right? But this car will be moving safely. So what we understand is that this friction is not a reliable condition, and as this friction, since it is not reliable, the maximum safe velocity dependence on this friction is very risky, and that is the third condition. Okay, if the friction is not sufficient, then obviously the vehicle will tend to skid off. So these are the conditions for significance of this max velocity. So what we understand, just summarizing, the maximum safe velocity, what does it depend on? It depends on friction, right? And what does friction depend on? Friction in turn depends on the nature of the surface of the tire and the road in contact. And this can be variable. As per this, then there is a likelihood that the vehicle can skid off or can remain with a nice grip on the curved surface. And this explains the state of significance.